Hello, my friends. Today we're going to talk about an absolutely extraordinary aviation story. There's an accident that happened in 1993, but it's one of a kind. Let me tell you about it. In Oxford, there's a parachuting association, which is more or less affiliated with the military, that is going to rent an Antonov 28. It's an Antonov 28 on a wet lease. That means it comes with its own pilots, and then the association, well, they bring the parachutists. They're going to rent it in Hungary. You should know one thing. Originally, it's a Russian plane that was registered in the Soviet Union. It's 1993, so the Soviet Union collapsed not long ago. And a lot of these planes and also these Soviet crews are going to end up on the Western European market. So the Antonov 28 arrives. It's the end of August, 1993 in the summer. So it arrives in the United Kingdom, and the next day it starts parachuting operations. So to briefly describe the aircraft, it's simply a twin turboprop. So it's a propeller plane, two engines, they're turboprops. And actually, someone could describe it as the poor man's twin otter. All day long, it makes repeated runs, so it makes pretty short flights. 10, 15, 20 minutes to go drop parachutists. So each time it takes on parachutists, takes off, gains altitude, they jump in free fall, and then it comes back to the ground. We're on the 13th, I'm not making this up, we're on the 13th flight of the day. The plane lines up on runway 38. Well, runway 38, runway 36, runway 38 doesn't exist. I don't know why I thought of 38. And actually there are 18 people on board. 19, there are 17 parachutists, and we have the captain and a first officer, a co-pilot. Both of them are Russian, and they came with the plane. In fact, they were the ones who brought it from Hungary to the United Kingdom the day before. They are experienced, there's no doubt, there's no problem with their skills. In fact, they are very competent people, as the rest of the story will clearly show. So they line up on runway 36, accelerate and take off naturally. No problem up to that point. They reach 500 feet. And what do they do at 500 feet? So at 500 feet, they flatten the climb a little to gain speed and retract the flaps. So the flaps are these surfaces that extend from the back of the wings on this plane, which allow the aircraft to operate at low speed. So we deploy them for takeoff and landing. But after that, they need to be retracted. So in this case, the two pilots realized that it's high time to retract the flaps. One of them grabs the lever and moves it to the flaps retracted position. On this aircraft, there are electric flaps. So it's a bit like in a Cessna 152. There's a small lever, you push it. And then there's a small electric motor that takes care of retracting or extending the flaps. What will happen? Well, when they retract the flaps, they only use one lever. Something terrible is going to happen. The flaps, they won't move. But what's going to happen is that both engines, left and right, are going to stop. It's as if a hand had shut off the fuel valves of both engines. So the fuel supply to both engines is cut off. They're going to shut down and the propellers will feather. So they'll align with the airflow to offer minimal resistance. Even better, or rather worse, I was going to say, the air brakes on both sides will deploy. I mean, clearly this situation has no future. It's very difficult to achieve prosperity from a plane that's stalling, that's at 500 feet. Both engines stopped, the flaps extended, and the air brakes fully deployed. An absolutely terrible situation. What's going to happen? The aircraft is going to drop like a stone. So the pilots are going to try to glide. Yes, but how do you glide with the air brakes out? They'll dive, but there's a field ahead. Luckily, there are no buildings or obstacles. There are fields. They head straight for it, and in a miraculous way, they manage to land in the field. Well, it's more of a moon landing than a regular landing. The plane is completely dented, the wings are broken, it will never fly again. It's written off by the insurance, it's over. But everyone is safe and sound. They'll get out, firefighters are coming, that's it, it's over. There was an accident, now we're in the aftermath. Authorities have been notified and will begin investigating. There's one thing you need to know. While the authorities were on their way, the pilots, well, trained in the Soviet style, got a little worried. They thought to themselves, what's going to happen? Are we going to end up in a gulag? Are they going to arrest us? So they took off and ran away. They just like that, sneakily, went to Heathrow Airport, took a plane, bam, disappeared. They were there, and now nobody knows where they are. So the pilots fled. So the investigation is going to be a little bit difficult for the British authorities because quite simply they didn't know this type of plane. It's the first time they've had an Antonov 28 wrecked in a field. On top of that, there's no black box, plus the pilots aren't there. So you can imagine how difficult the investigation is. Nevertheless, they will slowly piece together the history and they will discover something absolutely extraordinary. They will discover a flaw in the construction of this Antonov. There's something you need to know before blaming Antonov. Antonov, fundamentally, it's a design bureau. It's an aircraft design office. You see, it's a Soviet office created during the Soviet era with offices based in Kyiv, Ukraine. So if you want, they are the ones who design the planes, but they may not be the ones who build them. They will draw them, prepare the plans, prepare the documentation, all of that. And then the planes are manufactured under license. You can see them being made under license in Kazakhstan, in Iran, in Poland. By the way, this particular one was made in Poland. They don't just make that. In fact, they don't just do drawings for that. They also design trams, trains, and rolling stock and all that. In any case, there's one thing. There's a gap between what the Antonov Bureau had designed and what the Poles had built, especially regarding the electrical system. Why? Because it's often like that. The bureau that sells the construction license, that sells the know-how, doesn't really have control over how, in the end, the manufacturing plant will interpret or sometimes even coldly modify, shamelessly modify its plans. And in that case, there's a modification, let me tell you. In the electrical system of the Antonov, we have most of the systems. So the air brakes, the flaps, the lights, the radios, engine controls, everything is electric and in direct current, as is often the case with Soviet aircraft. But as it was at the time, a lot of aircraft, even Western ones, which actually used a mix of alternating current and direct current. The problem with direct current, unlike alternating current, is that it has chemical effects. It has chemical effects. That's why it was abandoned, because it tends to create what's called contact corrosion. That means it tends to create and accelerate corrosion at certain contact points. It tends to deteriorate a number of connections, of joints, and so on. So alternating current is preferred, but on this plane it was entirely direct current. Now, when you look at how it works on this aircraft, well, for each system, there's a cable that brings the positive. So the positive comes in. For example, on the flap motor, there's a positive that comes in. But what about the negative, the minus? So the minus works like in cars. It doesn't necessarily go all the way back to the battery. The minus will go to the ground, to the airframe. So the metal will serve as a common ground, so it will act as the negative pole for all the devices in the plane, for all the equipment. So the battery has its negative pole connected to the metal. Everything else is connected to the metal the same way. All right, we do this. We also find this in automotive electricity. So here's the problem. The thing is, to connect to the metal, what the Antonov Design Bureau had done was design several ground connections. That means, for example, the engines each one had to have its own fuel management system, regulation and propeller governor. And everything had to be individually grounded to the airframe. Each should have had its own ground connection. The office in Poland, well, the manufacturer in Poland, they wanted to keep it simple. What did they do? They connected all the negative cables together and brought them to a single point on the metal body. So on paper, it works very well. We start the plane, everything works fine, except that we've created a single point of failure. That means we've created a unique point of breakdown. We don't have any redundancy anymore. What's gonna happen? As the years go by, we'll have this single nut and this single bolt that go into the sheet metal to provide the ground connection, and they're gonna start experiencing several things. First, corrosion, carbon buildup, and then also they start to move more and more. What's gonna happen at that point? The resistance will increase. The resistance at this ground point will increase. So, the day the pilots, we reach a critical point. When the pilots retract the flaps, what happens? At the moment they retract the flaps, we have a circuit for the flap pump, for the flap motor that is open or rather closed. So the electricity has to return through the metal sheet, but when it gets to the sheet, what does it encounter? It encounters resistance. At the ground connection, there is high resistance. So, since there is high resistance, what does it do? Remember, electricity always looks for the path of least resistance. So the resistance that should normally be extremely low is actually high. The electric current will start to flow back through the other circuits that are connected at the same place. So it will start to flow back through the other circuits, especially the engine control circuits. So the relays that allow the propellers to be feathered receive electricity in the wrong direction. This means the electricity will flow backward. Except that these were direct current relays that didn't have polarity, if you will. They didn't have polarity. They could operate the same way whether they received electricity in one direction or the other. So even if they received electricity in reverse, they still worked. So both relays closed as if they had received electricity. And what did they do? So in 1 second, one after the other, they feathered both propellers. So that's the first thing that happened. Secondly, on the Antonov, we had decided to install a device that limits the loss of symmetry in case of engine failure. So what did we install? We installed an automatic system that detects, for example, let's say the left engine has feathered, okay? Engine number 1 has feathered. It has stopped. What do? We deploy the lateral control spoiler on the other side, so the one on the right, to reduce the asymmetry. But the system wasn't smart. It's an automatic system that thinks left engine failure, aileron, right spoiler deployed. Engine 2 or right engine failure, left spoiler deployed. Since both engines failed, both air brakes deployed. So you see, we have a bad design. We have a design that is not followed by the manufacturer. We have poor maintenance, probably an aircraft that has suffered from corrosion and all that. So we have all these problems that are going to add up that day. And the bottom line is that, well, here we are. We end up with a flap lever being moved, 2 engines that stop, the spoilers that deploy, and the plane goes down. So they could have, and they should have actually, at the time it was commonly done, installed unidirectional diodes as well. That is, their one-way diodes. You can think of them as a one-way valve in a hydraulic circuit. It allows any electric current to pass in one direction, but not in the other. It wasn't done. If it had been, this accident wouldn't have happened, but it wasn't. The cables were just connected, and if current flowed back, it did. That's it. So that's it. It's an accident that made it possible to discover this very particular flaw. So afterwards, this aircraft was sold again, and it had this model of aircraft, not the actual aircraft, because the one that crashed was scrapped, but the aircraft had another life. They called it the Coyote, and it was sold to the US Army. And actually, there are some images. It's no longer in operation. The last one was retired a few years ago, but for 10 or 15 years, there was an aircraft called the Coyote, which was a twin turboprop that was operated by the US Army, In reality, it was a modernized version of the Antonov 28, which was somewhat refurbished. They changed its passport. It suddenly became Polish instead of Soviet or Russian, and then it was sold to the US Army. So there you go, my friends. Thank you for watching this video. Of course, any how do you say in literature, any resemblance to events, right? Recent ones would be purely coincidental. See you very soon. Subtitles.